Science.
A very good morning to our lecturer, Professor Madhya Dr. Tan Jun Chuan, and my team member. My name is Goh Han Shen from UTAN University, Technical Malaysia, Malacca. Today we are going to presentation and the title is related to Green Theorem. Firstly, Green Theorem gives a relationship between the line integral of a two-dimensional vector field over a closed path in the plane. And the function of Green Theorem is used to transfer a line integral into a double integral, or used to transfer a double integral into a line integral. If you want to use Green Theorem, the first thing is to check is make sure that the circle region is non-conservative force field. There are two conditions in here. One is oriented counterclockwise and another is oriented clockwise. Conservative force field means is the starting point and the end point are the same for a closed circle, so that we can conclude that that is a non-conservative force. So we can see the counterclockwise first in here, and the formula is integral the circle. This one is mean Green Theorem, F multiplied with dr. So in here, we should make a cross multiply with G first, then F. Means is G multiplied with ds minus F multiplied with dy. So we can get the formula here, double integral del G per del S minus del F per del Y dA. dA means two dimension, which is can ds dy or dy ds, or in a polar form, r d theta. And the right hand side, oriented clockwise, the formula is same with left hand side, counterclockwise, but here we should multiply with F first, then G. So we can get double integral R delta F first, delta F per delta Y minus delta G per delta S. That is a formula for oriented clockwise. That's the outcome in this slide. Based on figure 1.1, let's see are positive oriented in clockwise, and the D are the region bounded by the C. So if P and Q are function of Sy defined on an open region containing D and have continuous partial differential there, so we can get the formula double integration del Q per del S minus del P per del Y ds dy. So now I pass the next part to my team member Noor Najwa to continue their presentation.
Hi, my name is Noor Najwa binti Muhammad Azri. I will continue this presentation by explaining the question. So the question is, using Green formula, evaluate the line integral of a closed curve C is x squared minus y squared dx plus 2xy dy, where the curve is the boundary of region R, given that x is greater than 1 and less than 0, y is greater than 2x and less than 2x squared in the counterclockwise direction. So firstly, we have to draw the region. As you can see at the slide, we have y-axis and x-axis. In x-axis, we have 0 go to 1. And for the upper boundary, we have y equal to 2x. And for the bottom curve, we have y equal to 2x squared. And we will go into counterclockwise direction. And for the solution in number 2, we have the line integral curve x squared minus y squared dx plus 2xy dy. For x squared minus y squared, this expression is our pxy. And we differentiate, and this is partial of p. We differentiate p respect to the y, and we will got negative 2y. And for the 2xy, we differentiate the partial q respect to the x, and we will got 2y. So this is green formula, and the answer we will got for q 2y, and for the p we will got negative 2y. So we will put this together on the green formula, and for that part Kit will explain to you. Thank you.
Hi, I am Taman Kit. So start the solution 3. So based on the solution 1 and 2, we can know this is the counterclockwise. So counterclockwise, we must find the dA. From the integration become double integration and find the dA. How to find the dA? dA is equal to dy dx. So here the solution. Integration 1, 0, 1, 0. This is mean the x. X is between 1 and 0, and here is y between 2x and 2x squared. So 2y minus 2y, how to find this 2y minus 2y is this solution from 2, from these two. X squared minus x squared dx is 1 to solution the y. So here is become 2 minus 2y, and the 2 and the x squared can solution, so it just become 0. So here is 2xy dy solution, differential x, so become 2y. So here you can see it is 2y minus 2y dy dA. dA is you like to put dx also can, no problem. So dy dA here is mean dA. So here next, so still same, integration 1, 0, integration 2x squared, here is y. So 2y minus 2y become 4y dy dA. So here we must pay attention. When the dy is in front of dx, so we must integration the dy first. And because the dy is, the y is has the unknown value. So in integration 1, 0, 4y integration, y integration y squared over 2, so become 2y squared bracket 2x squared dx equal integration 1, 0, substitute the 2x and 2x squared into the y squared. So here become x squared minus x4 dx. So in the solution until here is easy. Just integration the dx. So integration x squared become x cubed over 3, x4 become x5 over 5. So the solution is x cubed over 3 minus x5 over 5 bracket 1, 0. So in the substitute the 1 and 0 into the x, and here become x over 3 minus x over 5. So the final solution is x16 over 15. Here is the region of the value. Yeah, thank you.
Hello, I am Nur Shakirin binti Niza, and I will present about analysis of the result. There are a few of analysis that can be obtained from our presentation. Firstly, we have understood the Green theorem and solved the question by using the Green theorem method. Secondly, we have using a mathematical software which is Symbolab to create a graph region and simulate the result. Lastly, we have assigned the project roles and completed the task in a allocated time. That's all from me. Thank you.